According to the 2020 National Electrical Code, the maximum length of a single run of NM cable for a 60-ounce subpanel is 50 feet. Therefore, using number 6/3 NM cable with ground for a 50-foot run is acceptable. NM cable must be securely fastened at intervals not exceeding 4 feet and 1/2 inches. This is important to prevent the cable from sagging or being damaged. Running NM cable over a finished basement ceiling without securing it is not a violation of the National Electrical Code, as long as certain conditions are met. Firstly, the cable is installed in a concealed location, such as above a drop ceiling or behind drywall. Secondly, the cable is protected from physical damage by other building components, such as insulation or joists. Thirdly, the cable is not exposed to excessive heat or moisture. The recommended method for running a subpanel feed over a finished basement ceiling is to use conduit and THHN wires. This provides the best protection for the cables and complies with the National Electrical Code requirements for securing. If you are concerned about securing the NM cable over the ceiling, you could consider the following alternative. 1. Install the NM cable in a cable tray or raceway that is securely fastened to the ceiling joists. 2. Cover the cable tray or raceway with drywall or other approved fire-rated material. This method provides additional support and protection for the cables while allowing for future access if necessary. Using number 6/3 NM cable with ground for a 50-foot run to a subpanel is acceptable. While running NM cable over a finished ceiling without securing it is not a violation. It is important to protect the cable from damage. If you prefer to use conduit and THHN wires, it is the recommended method. However, if you want to minimize damage to the ceiling, consider using a cable tray or raceway to securely fasten the NM cable. When running electrical wiring, including NM cable, several factors must be considered to ensure safety and compliance with the National Electrical Code. These factors include ampacity, which is the current carrying capacity of the wire, voltage drop, proper grounding, and protection against physical damage. The ampacity of a wire is determined by its size and insulation type and must be sufficient to handle the load it will carry. Voltage drop occurs when the voltage at the end of a wire run is lower than the voltage at the source due to the wire's resistance. Excessive voltage drop can cause equipment to malfunction or not operate properly. Grounding provides a low impedance path for fault current to return to the source, which helps to protect against electrical shock and fire hazard. Protection against physical damage is essential to prevent the insulation of the wire from being damaged, which could lead to short circuits or ground faults. National Electrical Code Article 334 covers non-metallic sheathed cable, which includes NM cable. This article specifies the requirements for the use, installation, and construction of NM cable. Some of the key requirements include that NM cable must be supported and secured at intervals not exceeding 4 feet and 1/2 inches, that it must be protected from physical damage, and that it must be properly grounded. National Electrical Code Article 310 provides tables that specify the ampacity of different sizes of wires based on their insulation type and temperature rating. These tables are used to determine the appropriate size of wire to use for a particular application. For example, Table 310.16 lists the allowable ampacities of insulated conductors rated up to 600 volts, not more than 3 conductors in a raceway or cable or earth, based on ambient temperature. National Electrical Code Article 250 covers grounding and bonding. This article specifies the requirements for grounding electrical systems and equipment to provide a safe path for fault current to return to the source. It also covers bonding, which is the connection of metal parts to create an electrically conductive path. When running a subpanel, it is important to properly size the feeder conductors to ensure that they can handle the load. The feeder conductors must have an ampacity equal to or greater than the sum of the loads connected to the subpanel. It is also important to properly ground the subpanel by connecting it to the grounding electrode system. This will help to protect against electrical shock and fire hazards. In addition to the National Electrical Code, local electrical codes may also apply. It is important to check with the local electrical inspector to determine the specific requirements in your area. Using conduit and THHN wires is generally considered the best practice for running a subpanel feed, as it provides the most protection for the wires and complies with the National Electrical Code requirements for securing. Conduit protects the wires from physical damage, and THHN wires are rated for higher temperatures than NM cable, which can be important in some applications. However, using conduit and THHN wires can be more expensive and time-consuming than using NM cable. If you choose to use NM cable, it is important to carefully consider the installation requirements and take steps to protect the cable from damage. This may include using a cable tray or raceway to support the cable, or covering the cable with drywall or other approved fire-rated material. When working with electricity, it is important to always follow safe work practices. This includes wearing appropriate personal protective equipment, such as gloves and safety glasses, and energizing circuits before working on them. If you are not comfortable working with electricity, it is best to hire a qualified electrician. The National Electrical Code is a comprehensive set of standards that covers all aspects of electrical installation. It is updated every 3 years to reflect changes in technology and safety practices. The National Electrical Code is not law, but it is widely adopted by state and local jurisdictions. In general, it is always recommended to consult with a qualified electrician or electrical inspector to ensure that your electrical work is safe and compliant with all applicable codes and regulations. Doing so helps to avoid potential hazards and ensure the long-term reliability of your electrical system. Also, it is essential to know that electrical work can be dangerous, and it is important to take precautions to protect yourself and others from electrical shock and fire hazards. Always turn off the power before working on electrical circuits, and use appropriate safety equipment. If you are not comfortable working with electricity, hire a qualified electrician. Remember to double-check all the connections to make sure that the wiring is wired up correctly. An electrical subpanel, also known as a load center or panel board, is a secondary distribution point for electrical power in a building. It receives power from the main electrical panel and distributes it to various branch circuits throughout a specific area. Subpanels are commonly used in residential, commercial, and industrial settings to provide localized control and protection for lighting, appliances, equipment, and other electrical loads. There are several reasons why you might need to install a subpanel. Firstly, to increase the number of circuits. If the main electrical panel is full, a subpanel can provide additional circuit breaker slots to accommodate new circuits without having to replace the entire main panel. Secondly, to separate circuits. Subpanels can be used to isolate circuits for specific areas or purposes, such as a workshop, home office, or outdoor lighting. This allows for better control and protection of these circuits. Thirdly, to reduce voltage drop. When running long circuits, voltage drop can become a problem. Installing a subpanel closer to the load can reduce voltage drop and improve the performance of electrical equipment. Fourthly, to simplify wiring. In large buildings or homes, it can be more efficient to run a single feeder cable to a subpanel and then distribute power to local circuits, rather than running individual circuits all the way back to the main panel. When planning to install a subpanel, there are several factors to consider. Firstly, location. Choose a location for the subpanel that is easily accessible, dry, and protected from physical damage. It should also be close to the loads it will be serving to minimize voltage drop. Secondly, capacity. Determine the total electrical load that the subpanel will need to handle and select a subpanel with sufficient capacity. Consider both the continuous load and the potential future loads. Thirdly, wiring. Determine the size and type of wire needed to feed the subpanel from the main panel. This will depend on the load and the distance between the two panels. Fourthly, grounding. Ensure that the subpanel is properly grounded to protect against electrical shock and fire hazards. Connect the subpanel's grounding bus to the main panel's grounding system. Fifthly, circuit breakers. Select the appropriate circuit breakers for each circuit in this subpanel. The circuit breakers should be sized to protect the wires and equipment they serve. There are several types of subpanels available, each with its own advantages and disadvantages. Firstly, main lug-only subpanels. These subpanels do not have a main circuit breaker. They are typically used when the subpanel is fed from a circuit breaker in the main panel. Secondly, main breaker subpanels. These subpanels have a main circuit breaker that can be used to disconnect power to the entire subpanel. They are often used when the subpanel is fed directly from the utility company. Thirdly, combination subpanels. These subpanels combine the features of both main lug-only and main breaker subpanels. The installation of a subpanel involves several steps. Firstly, turn off the power. Before starting any electrical work, turn off the power to the main panel and the circuit that will feed the subpanel. Secondly, mount the subpanel. Securely mount the subpanel to a wall or other suitable surface. Thirdly, run the wiring. Run the feeder wires from the main panel to the subpanel. Be sure to use the correct size and type of wire. Fourthly, connect the wiring. Connect the feeder wires to the appropriate terminals in the main panel and the subpanel. Be sure to follow the manufacturer's instructions. Fifthly, ground the subpanel. Connect the subpanel's grounding bus to the main panel's grounding system. Sixthly, install the circuit breakers. Install the circuit breakers in the subpanel and connect the branch circuit wires to the appropriate terminals. Seventhly, label the circuits. Label each circuit in the subpanel to indicate what it serves. Eighthly, turn on the power. Once all the wiring is complete and the subpanel is properly grounded, turn on the power to the main panel and the subpanel. Ninthly, test the circuits. Test each circuit in the subpanel to ensure that it is working properly. When working with electricity, it is important to follow safe work practices. Firstly, turn off the power. Always turn off the power before working on any electrical circuits. Secondly, use insulated tools. Use insulated tools to protect yourself from electrical shock. Thirdly, wear safety glasses. Wear safety glasses to protect your eyes from flying debris. Fourthly, follow the National Electrical Code. Follow the National Electrical Code and all local electrical codes. Fifthly, hire a qualified electrician. If you are not comfortable working with electricity, hire a qualified electrician. The National Electrical Code provides specific requirements for subpanel installations. Firstly, Article 220 covers branch circuit, feeder, and service calculations. This article provides the methods for calculating the load on a subpanel and determining the appropriate size of conductors and overcurrent protection. Secondly, Article 250 covers grounding and bonding. This article specifies the requirements for grounding the subpanel and bonding metal parts to ensure a safe path for fault current. Thirdly, Article 310 covers conductors for general wiring. This article provides tables that specify the ampacity of different sizes of conductors based on their insulation type and temperature rating. Fourthly, Article 408 covers switchboards, switchgear, and panel boards. This article specifies the requirements for the construction, installation, and protection of subpanels. A few common mistakes to avoid during subpanel installation are undersizing the feeder conductors, improper grounding, incorrect circuit breaker selection, failure to label circuits, and not following the National Electrical Code. Avoiding these mistakes can ensure a safe and reliable subpanel installation. The proper maintenance and inspection of a subpanel includes visually inspecting the subpanel for any signs of damage or corrosion, testing the circuit breakers to ensure that they are working properly, tightening all connections, and cleaning the subpanel to remove any dust or debris. Regular maintenance can help to prevent problems and extend the life of the subpanel.